Good morning, everyone. How exciting. We are starting a new week. Week 3. No, it's not. It's week 2. Oh, look at this. I've moved us up a week already. Okay, so it is week 2. It is lecture 3, and we are going to have even more fun today, I guess. Hope everyone had a good weekend and enjoyed a nice picnic. We did have a nice day in there on the weekend. I saw lots of people enjoying picnics on the Saturday, and as I left the park with my dogs, got in the car and it started absolutely pouring down with rain, and I just thought, oh well, that's put a bit of a dampener on those picnics, but the Sunday was glorious. All right, well, I hope that you're all ready to get more into it today. We're going to look at some more if statements. We're going to have a closer look at Scanf a little bit. We're going to do my favorite thing of all, which is break things. And we're going to also start learning about structs as well. So in the chat today, we have the wonderful Catherine and the wonderful Shrey and also the wonderful Tom. So please feel free to ask all your questions. The three of them are in the chat ready to answer your questions. Okay, so let's get started. Okay. Oh, how did I go back to the very first one? Okay, so last week we started looking at C. We wrote our first hello program. You guys went off to your tutorials. Your first tutorials, you met all the awesome people in your classes, you met your amazing tutors, and then you also got to write your own programs, which is pretty exciting. So you got your first taste of printing stuff out as well, your first taste of new line and how to move things over to a new line. Yeah, you got a first taste for using a bit of Linux. Well, maybe some of you it wasn't your first taste. You compiled, you ran your code, you used printf, you used scanf a little bit. And you kind of started out, you learned about variables and some maths. And so today what we're going to do is we're going to continue with more complex if statements. I wanted to look more closely at logical operators, so using and or in your code as well to describe a condition. And then we're going to change some ifs and elses a little bit better, and we're going to talk about breaking things. And then I'll introduce you to a new concept of structures, which is super exciting. Okay, so where is the code at? The live lecture code can be found at this link here. And this time I have actually made it all available in advance. So super exciting, you can see it all. So this is how we're going to, first of all today, we're going to go straight into a bit of code. And I'm going to do the problems in the gedit application. So we're going to look at if statements with logical operators in a piece of code called iflogic.c. We're going to look at if statements with some char and also look at how scanf works with char as well in upper.c. And then we're going to do some harder if logic, and we're going to chain a little bit together, break a few things, just kind of have a bit of a good time with it. And we're going to do that in dicechecker.c. All right, let's get to the code. Haha, it's like magic. I've swapped screens to my code. Okay, so the first piece of code we're going to look at today is we're going to look at some logical operators. And in the lectures last week, you guys learned two logical operators, and it was the logical and, which was using two ampersands. And that means that you can say two statements together, something and something. And what it means is that both something and something have to be true for that statement to be true. So it is exactly the same as how you use and in the way that you speak. So if you want something to happen and something else to happen, that means you want both of those things to happen. We also looked at something called or, which is using two dashes like this if you want to put it in code. And a logical or is again exactly the same as how you would speak in using just your language. So if I want to watch particular TV show or another particular TV show, that means I'll watch either one or the other. not necessarily both. And that's how a logical OR works as well. And so we'll be able to see it in action in a second. So let's get into a little bit of code. So don't forget, when you've got your piece of code, you open up your file, you've got your header file, which says what the program does and who you are, and perhaps a date. And then we always hash include something, and this time we're hash including our stdio.h file, which is a standard library that C provides. So what are we going to have? So first of all, let's look at problem number 1, and we'll try and solve problem number 1. So problem number 1 is let the user provide you a number, and you then check and decide how many digits that number has. So let's talk about the problem that we have, okay? So let's try and break it down into steps. So first of all, we need to let the user provide us, a number. So, okay, then it looks like we want to check and decide how many digits the number has. And then we're going to want to print out how many digits that number has. So there's 3 particular steps to this problem. So if you want the user to provide you a number, how would you go about doing something like that? So how do you take input from the user? What would be something that we could use to take input from the user? Yeah, Scanf, excellent. So this is going to be a good opportunity to use Scanf. Then we have to check for number of digits, okay? So what are our options? The number can have either 1 digit, and in that case, what would the number be if it has 1 digit? What would it be between? Yeah, so 0 to 9. So that means we have certain combinations here. And the combinations are, if we're between 0 and 9, we have 1 digit. What are other? Tom's got something else. Yes, what about negative numbers? So in fact, you can have 1 digit here if you are between -9 and 9 inclusive, okay? Or -10 and 10. If you're between those, but not including those. So if you are, opposite way, greater than -10, and you are less than -10, you're going to have 1 digit. Yeah, because you've got to include the negative numbers as well. And in that case, then you can have, if you're between 10 and 100, including the 10, because you didn't include the 10 before. So if you're between 10 and 100, but not including 100, because 100 is 3 digits, you're going to have 2 digits. But also, that's just considering, so that's just considering our positive numbers. So if we consider negative numbers, then we have to go the other way as well. So that means if you are between greater than -100, but not including -100, and you are less than or equal to -10, then you have 2 digits. And anything more than those will perhaps be 3 digits or more. Yeah? So we'll have a look at how to write that. And then to print out the number of digits, now that you've used your lovely scanf, you will now make use of the printf function as well. Okay, so let's see if we can actually write some code for this. So first of all, we need to let the user provide a number. We know that we're using scanf. When we take in that number, that means we need to store that number somewhere. It can't just, we can't just ask for a number and have it go nowhere. We need to be able to store it somewhere. So that means we're going to need to have a variable. So first of all, we're going to need to have a variable. And what is that variable going to be? Is it going to be an int, a double, or a char? Well, we're taking in a decimal number, a decimal digit, which means that it's going to be an int. So it's going to be of type int. And Remember, always we want to have a really nice name for our variable as well that actually, tells us what it is that we're taking in. So I'm going to be really, really creative and maybe call it int number. Okay, now you want to have some sort of prompt to ask the user for the number. So I'm going to use a printf statement, and I'm going to use that printf statement to ask the user what number they want to enter. Okay, and then I need to take in what they have entered. So I need to be able to scan in the number that they have entered, and this is where I will use Scanf. I'm going to take in the number. Because it's a number, I'm going to use a %d for a decimal number, and I'm going to pop it into my variable name number. Don't forget, when you're using the scanf function, you need to use the ampersand to say which variable name it's going to go into, and that's because you're looking for that particular address of that variable name when you overwrite it. And we're going to talk more about it in the later weeks, why we use that ampersand. But for now, just remember to use the ampersand. Okay, so this is really doing our part one. Okay, so this is step one. We've let the user provide us a number. We now have a number that we can use to play around with, so to check whether or not how many digits it actually has. So we have a few possibilities here. So the first possibility is that that number is going to be between -10 and 10. The next possibility is that the number is going to be 2 digits, or it's going to be between 10 and 100, or -100 and -10. Okay. So what happens here is that you are going to have to make a decision. And if you have to make a decision, then that means that you're going to have to use an if statement, okay? So anytime you need to make a decision, anytime you're asking a question, so in this case I'm asking, is this number between -10 and 10? So that implies to us straight away that I'm going to need to use an if statement, okay? So let's do our first if, okay? So if, and now I want to find out if the number is between -10 and 10. So in maths, we can kind of make this type of statement, that that number x is between -10 and 10. This is not something that is possible in C, okay? So in C, to say something like that, we need to say that the number is greater than -10, and also the number is less than 10. So you use the and symbol to be able to kind of have this type of inequality that you so often see in maths, okay? So you can't just go, okay, -10, less than, okay, we're going to compare it to number, and less than 10. So you can't do that in C. You have to really be a bit more specific. So either the number has to be greater than -10, and the number has to be less than 10, okay? And I'm not including the -10 and the 10 because 10 and -10 are both 2-digit numbers. So that's why it's just less than and greater than symbols. Okay, and then we open our curly brackets because we're going to have a block of code that is associated with that if statement. So if the number is between -10 and 10, then this number has 1 digit, and I'm going to print out that it has 1 digit. So %d, so this number has 1 digit. Okay, so that's great. So that's one option done. But now we have a few other options as well. So we have a possibility of 2 digits as well. And in the 2 digits, it's going to be, okay, the number has to be greater than or equal to 10, and the number has to be less than 100, or the number has to be greater than -100 and less than or equal to -10. I'm really having trouble with my less than and greater symbols. So there is another combination then. So either I can make this statement by saying else if, which someone has said in the chat, which is very nice. So let's try it with that. So else if, I will have potentially a different combination. And the different combination is going to be that my number is going to be, okay, this is going to be a long one, okay, because there's a few things to consider in 2 digits. So let's do the positive numbers first. Okay, so in positives, I would have to be greater than 10 or equal to 10. That gives me 2 digits. But also I have to be less than 100. I had to think twice about that less than symbol. So that gives me the positive number 1. But now I need to check for the negative as well. And this is where I'm going to use the logical OR, okay? Because I'm going to check whether it is now in the negative side as well. So is my number, it has to be greater than or equal to minus 10. And it has to be less than, no, greater than minus 100. There we go. So it has to be, that's wrong, I feel. That is wrong. It has to be greater than or equal to negative 10. No, it was right. It was right. Oh my God. Early mornings is not my time to shine. That's all I have to say. You know, does anyone ever still think, you know, oh, that's the big crocodile and it's going to eat the big number from primary school days? I feel like every time I see a less than or equal symbol, I still think that. Okay, and in that case, we have two digits. So we're going to printf statement, and we're going to have that our number, whatever the number is, has 2 digits. Okay, so what do we get? Got 2 digits, okay. And then what else? I mean, we could keep going. We could keep going for a 3-digit. We could keep going for a 4-digit. We could keep going quite a bit. But I think maybe let's just see how else works, okay? And we'll say that else, it has more than 2 digits, okay? So let's just say else. And we'll say that number has more than 2 digits. But you could obviously keep checking other things as well. And I'm sorry, my code doesn't look very neat and very nicely indented because my screens are zoomed in so that you guys can see, and what's happened is that it keeps moving things over different lines. But I will point out a few things. Okay, so how is that? How is that looking? What do you think? Does that look like we've considered everything that there is to consider? So we've done all 3 steps. We've taken in a number, we've compared it, and then we've also printed out the number of digits, okay? I think the only thing I might do is I'll just put a new line everywhere, just so that it looks nicer. Okay, so why don't we try it out? So let's run it, let's compile it. Okay, great. I forgot a bracket somewhere, so let's have a look. Hang on, I can see someone's already asking. We're about to break it. Let's not break it first. Let's just decide what's going on. So I've got an error somewhere. I forgot a bracket, and I can see that it is over here. I forgot a closing bracket. So when you see these types of errors on your compiler, you can see there's a few things happening. Just look at the first thing, fix it first, try it again, okay? Because sometimes the first thing will cause a whole bunch of errors to show up as well, and actually it's only just that one error. Okay, so that compiled successfully, so now let's see if we can run it. So if we type this in, I'll enter the number 4, 4 has 1 digit. If I run it again, I enter the number 100, that has 2 digits, okay? If I run it again and I enter the number -10, that has 2 digits as well. And so notice whenever I'm seeing whether my code is working or not, I will always put in a number that is kind of in the middle of my AND. So somewhere in the middle of -10 and 10 is going to be positive. I might do a -1 as well. And then I always try my boundaries. So the boundaries are those that are sitting on the outside here. So when I say my number is between something and something, they're like my boundaries. And that's what I want to check. I want to check that those boundaries are working. That is most commonly where errors occur, where you've forgotten to do something. Oh, someone has said 100 has 2 digits. So you see, so there we go. So that's number 1 problem now. And why is that happening? Who knows why? Wait, exactly. 100 has 2 digits. And why is this happening? Why is it saying that 100 has 2 digits? What do you guys reckon? Yeah, well done, Lisa. It's not working for 100 because I use this else statement here, okay? And why do you think it's not working if this else is there? What do you reckon? Yeah, because it says greater than 100. So I could perhaps then say else if and give it a condition, a more specific condition. So now if my number is greater than or equal to 100, or my number is less than or equal to -100. Okay, and then let's see what it does now. So I'll compile it again and I'll run it, and let's try it for a boundary 100. And it's still saying that it has 2 digits. Oh no, what could it be? What do you guys reckon? Okay, someone has picked it. Yep. Well, the else in this case, it wasn't stuffing it up to say, but you have to try different things when you get an error. Sorry, I'm trying to demonstrate that you will often get errors. The errors often occur on boundaries conditions, okay? And we will look at why it originally didn't work, okay? So, and someone has picked it actually in the chat. Sorry, the chat is moving very fast and I'm having trouble scanning it and scanning on my other screen. So here I said, if the number is greater than -10, and the number is greater than -100. Does that make sense? Okay, so the error is happening on line 32 here. I'm not checking for the right thing. Yeah? Okay, so let's have a look. So if the number is greater than or equal to 10 and the number is less than 100, so that makes sense. That's perfect. Or if the number is greater than or equal to -10, and if you're in the negative numbers, if you're greater than, you're going to go to -9, -8, -7, -6, -5, and so on. But that's not actually what I want to do, is it? I want to go the other way. And then if the number is greater than -100. Okay, so if we run it now, and we'll try it for 100, it's now going to say that it has more than 2 digits, okay? And the reason was because here I was going the wrong way, okay? Because I was saying if the number is greater than -10, which is going to -9, -8, -7. Okay, so this is one way to do it, okay? There's obviously a few ways to solve different problems, okay? Now, someone in the chat, I didn't quite see it, said, okay, what happens if someone doesn't put in a number? Which is, of course, how we can break something. So what's a way to break it? A way to break it is if someone says, please enter a number. Oh, you know what? I don't feel like it. I'm going to be difficult and I'm going to put in enter, let's say. And look at this. When you put in enter, it actually doesn't do anything, okay? Now, the reason it doesn't do anything is because when you use this scanf here and you scan in a number, so when you scan in a %D, what happens is that scanf is waiting to see a %D. And when it does this, it skips any leading white space. So anything in front of it, it just ignores. It's waiting to see a number. So even if I put in a number now, it's going to work. Okay, so when you scanf a %D, it skips over all the white space. But what happens if what else can I put in that would break it? I mean, not that that broke it, but what else can I put in that will break it? Yeah, a character. Well done. If I enter a character, oh my goodness, it all goes crazy, okay? Well, not crazy. It just really doesn't want to do it, obviously, because I haven't told it I'm going to enter a character. I've said to it I'm going to enter in a %D. So what happens, what scanf does, okay, is scanf tries to read a number. It kind of goes to this, sees that it's a character and says, actually, there's nothing for me to read here. I'm going to fail. I'm not going to read anything because nothing has happened. There's nothing for me to take in. But I'm going to keep going. The program keeps going. It doesn't actually quit, okay? So even though scanf has failed and it's got nothing inside this variable, the program continues going. Your code continues. So when you get to the first line where you need to do a comparison, where you've got your lovely variable here, there is nothing inside that variable, which is why it can no longer do a comparison, okay? So how can we make sure that scanf behaves for us or that scanf is being nice to us? We need to help scanf. We need to check whether or not it's actually been successful in reading anything, okay? Or whether it has failed, okay? So there are ways to do it, okay? Scanf is actually a function, as you know, so it comes from this lovely library that you borrowed over here. It comes from this stdio.h, so that's where it's defined. And we're borrowing it, and what scanf has is scanf has some special magic powers. Well, not magic powers, nothing is really that magic. It's pretty well defined, but scanf has a return value, okay? It's not just it, and it will return the number of things it has scanned in. Okay, so what that means is that if scanf has a return value, we haven't assigned that return value to anything because we don't really care for it right now. But if we ever want to error check, we need to check that scanf has actually been successful, okay? So there are a number of ways to do it, okay? Let's do it in the simplest possible way first, and then we can look, as we go on today, we can look at, shortening up the code and making it a little bit more efficient looking, well, nicer looking as well. So scanf returns to you an integer. It returns to you the number of things it has scanned in. So why don't I have this lovely variable here called scanf return, okay? And I'm going to assign whatever this function returns to this variable. So if there is one thing to scan in here, if it scans it in successfully, so if something goes inside this variable, I would expect it for this scanf return to be equal to 1, okay? So let me show you this printf. I'm going to use a printf statement to show you what scanf returns. Okay, and then we're going to delete it. So the only purpose of this printf statement is to show you what it has given us. So what's sitting inside that variable. Okay, so now if I compile it, I'll save it. I'll clear this screen so you can see. That's not what I meant to do. Okay, compile it first, then let's run it. Now, if I put in a number, okay, then it has returned, oh, I should have put a new line, I'm sorry. See how it's not very clear what it's returned because I put in 1 and then I also am doing the reading of what 1 is. Okay, let's compile it again and let's run it again. If I put in the number 1, you can see that Scanf returned 1 because I've read in one thing, okay? So that means I have one digit, so I have something inside that number that I'm going to compare now. So I can use this to check that Scanf has returned something. And I only have to run this code if Scanf has actually scanned something in, okay? So how will I do that? What do you guys reckon? How will I check that Scanf is equal to 1? Then I can do that code. Or if it's not equal to 1, then I'm going to exit out of this program or provide an error that nothing has been scanned in. So I can check here with an if statement. So if this scanf return, I can say if it's not equal to 1, then I'm going to provide the user with an error, okay? And your error should be quite nice. I can have a big if statement around everything, and someone said if scanf is equal to 1, I can absolutely do that as well, okay? Now, if I do that, then it will only consider my lovely so only for 1, okay, which is fine. But when I do not equal to 1, then that considers a whole bunch of things, okay? This just means it's not equal to. Whenever you see this exclamation mark, it means not. So if this scanf not equal to 1, then I want to exit out of here. So I can say a number was not scanned in. And then I'm going to exit out of it. Now, if you remember, normally we return 0. If we want to exit with an error code, I'm going to return 1, okay? That means that the program has not run successfully. And this is just standard the way we write code, okay? So if a human then was reading over your code, okay, they know that the standard is 0 if it has finished successfully and 1 if it hasn't finished successfully. And in a few weeks, you will also see why this is so useful to find out if something is successful or not successful. Because once we start putting things out to functions, we need to know if that function has returned us anything or if it ran with an error. So now if we compile this and we run it, and now if I put in a character to try and break it, I'm going to get an error, a number was not scanned in. Because of this return 1, the program will exit, okay? And that means, what that means is that it's not going to keep running and it's not going to encounter errors. And also, I'm sorry, I get very annoyed when I forget to put the new line because it looks so horrible. So don't forget the new line as well. And I'll just rerun it so that it looks pretty on the terminal. So now if I tried to put any character, it says error and number was not scanned in. Okay? All right, so that's good. That's good. What if I was trying to scan in 2 numbers, okay? What if I was trying to scan in 2 numbers? Let's say I'm going to scan in 2 numbers and I'm going to add them together, okay? So someone has a, don't we need an else statement after this error? Return. So when you encounter this return, okay, you will just exit out of the program. You're not going to run any more code. And you're only going to enter this block of code. You're only going to go into this if statement if this value here is not equal to 1. So that means if you haven't actually been able to scan anything in. So you don't always need an else statement. You don't always need an else if statement. Sometimes it's just one if statement to check if something has worked or not, because inside that if statement you have exited the program. So you're not gonna come back to keep running anything else. Okay, let's have a look. So what if we're gonna scan? What if we're gonna be tricky and we're gonna scan two things? Let's do two numbers, okay? So let's say I'm gonna scan in int number 1, and I'm gonna scan in int number 2. Okay, I'm going to have this scanf return as well. Okay, so please enter. Should we do two numbers at the same time? So you're able to do two numbers at the same time. So the way you do that is you scanf %d%d, and what it will do is it will remember that when you're scanning in %d, it doesn't care about any leading space. So it's going to scan in this space here, discard it, and look for the next number. Okay, and we're going to pop those things into number 1 and inside number 2. Okay, so now I'm going to put this statement back so that you can see what scanf has returned for us, because scanf is going to return something else, okay? It's not going to return 1 now. If it is successful in scanning in two things, it should return 2, okay? So here it should return 2 if I've scanned in two things. So now I'm really needing to check, because I need two numbers. And if I have two numbers, then I'm okay to go on. And what I'm going to do is I'm going to add those numbers together after I check that those numbers were scanned in. And then I'm going to compare these things with the sum. Yeah, it should have just kept it named number, but I was trying to do nice names. All right, let's try it again quickly. Okay, so now if we compile it and then we run it, please enter two numbers. Okay, let's do two numbers properly. If I've done 1 and 3, you can see my scanf returned 2 because it's scanned in both of these numbers. The sum of these two numbers is 4, and 4 has 1 digit. So how can I break it now? Neil, there is a replace all function in get_it, but whenever I use replace all, it replaces everything under the sun, and then I make mistakes. Okay, so let's run it again. Okay, how else can I break it? Yeah. What else can I do? How else can I break it? What if I put in two numbers? What if I put in one number and a character? What do you think it will do then? What will scanf return if I put in one number and a character? Yep, so 1 int, 1 char. And it's going to return 1, okay? And the reason for that is because I have 1 here, so it scanned in the first number successfully. It went looking for the second number, and there was no second number. So it did get 1 successfully, but not the second one. Well done. If I put 3 numbers, okay, what I get, it's still going to return for me 2, because all it does is it scans in the first 2 numbers. It doesn't care about anything else. It's not looking for anything else. If you call scanf again now, then it will scan in this third number, okay? But what happens if I do a character first and then a number is that scanf will not scan anything in, because it will start looking, it will get nothing, and then it will just quit out, okay? So that is the lovely scanf, which has so much possibilities. And now we're going to start looking at it in terms of doing some letters as well. Okay, so if any questions, just keep popping them in the chat. I think, Tom, would you like to say anything more about our lovely number fiasco?
Yeah, I think that there were quite a few questions earlier in the chat just about the not equals 1 and not equals 2. I think you may have clarified them for some people, but it might just be worth going over really quickly just to be super clear. We expect that scanf should, if it's all worked correctly, it will return the number of things that it scanned in. So it's not what it scanned in. So if you scan in the number 100,000, it will return the number of things that it scanned in. So if you can show the scanf, Sasha, a great way of figuring that out is count the number of percents in that string. So if there are 2 percents that you're asking to scan in, so %d and %d, then scanf should return 2 because you're trying to find 2 things. And then if scanf can't scan in those things, for instance, because you type in a letter rather than a number, or because you haven't provided enough input, then scanf will return something other than 2. And if it hasn't returned 2, then you know that it hasn't worked correctly. That's sort of paraphrasing what's already been said in chat by Shrey and Catherine, so I just wanted to make sure that that was on the recording too.
Yeah, thank you, Tom. So so scanf returns the number of things that it has scanned in, okay, and it just keeps looking. So when it scans %ds, it just kind of walks over all the leading white space. It doesn't care about spaces. It doesn't care about enters, as you saw. I could do, I could actually do this, and I could put in the first number, and then I could press enter a number of times, put in the second number, and it still scans it in successfully. So it ignores anything that happens in between any of that white space that happens, okay?
There was one other thing in the chat that came up briefly that might be worth just mentioning, which is how the %ds in a scanf and the white space work together. I know you're planning on talking about this a little bit more in a little bit, Sasha, but it's worth noting that pretty much always in 1511, the best way of writing a scanf is just a %d and then a space and then a %d, for instance. The white space in the string doesn't matter too much, except for one thing that I think Sasha's about to talk about. But but generally when we're writing things out, we'll write %d space %d space %d, and we're being scanned in 3 integers.
Yeah. So we're about to talk about, I know I've kind of led you to this white space and pointed it out. So we are about to make it clear why I've done that. It's all about to become less magical. So let's move on to our next program. We're going to do something very simple first. I think we'll do about 10 minutes before we take a little break, okay? And then we'll continue on after that. So I wanted to do one that kind of demonstrates the use of the logical ifs, but also that plays around with characters, which we haven't done too much of. So last week we talked about the fact that actually characters are stored as ints in C, and that means that you can do mathematical operations on them. And they are indexed by the ASCII table. So if you look at the ASCII table, you know where you're at, and that means that you can kind of move around. However, out in the real world, you don't really need to know the ASCII table. You don't really need to know exactly what number each letter stands for. That is absolutely not what you need to do. What you really need to learn is how to manipulate those characters by doing maths on them. And that's kind of what we're going to aim for here as well. So let's say we have a program and now we want to convert a lowercase letter to an uppercase letter. So again, we have a few steps. A user will input a lowercase letter and then wants the computer to output the same letter but in uppercase. Okay. So we've got ourselves in a sort of 2-step situation, well, 3 steps again. So first step is we have to read input from the user. If only I could spell. Okay, so we read input from the user. And then what do? We need to somehow convert that input from lowercase to uppercase. and then we're going to print out the uppercase letter. So let's have a look at it without sort of doing any code first, and then we're going to, then we're going to talk about it. Okay, let me clear this. And what I'll do here is I'm actually going to stretch out the screen so that you can see the ASCII table, and we're going to talk about how to do that. Okay. So remember, if you want to see the ASCII table, you just type in ASCII/D. And let's have a look. So let's say we're putting in a lowercase letter. So lowercase letters, I can't highlight downwards, but they're from 97 down to 122 inclusive. So let's say we're going to put in a little c, okay? That's number 99, okay? And we want to convert that little c to a big C. So we want to take it over here to 67. So we're going to have, let's say, for example, the input is little c, and little c is, oh my gosh, it didn't take long for me to forget, 99. Okay, and we want to output capital C, which is 67. Yes, 67. Excellent. I'm like, I remember that 65 is A, and then having to go down as well. Okay, so what have we got then? Okay, so we need to go from 99 to 67. So how do we play around in the alphabet? I don't know if anyone ever done those weird, like there's these puzzles where you have the different letters and the letters might stand for a number and you have to figure out which number is which letter. If you have done those puzzles, then you will be well placed to play with this as well. Okay, it's kind of similar. So how do we work out how to move around? So the way we index an alphabet really is that kind of, we have 26 letters in the English alphabet, yeah? And we can figure out where things are if we know what number it is from A, because there is, so because there's 26 letters, you can't really have a difference that's going to be, there is a way to do it where you're not subtracting just a number. Okay, so you guys are right. You can subtract 32, and that's fantastic. But that is not going to give you great results every time, because you have to remember these numbers. And in coding, it's not about remembering the straight up number that you're going to do, because if someone is reading your code and they're going to go, why are you subtracting 32? What does 32 mean? It's not, it doesn't really make sense. So the way we do it is we actually look around at how far away you are from A, okay? So if we have our little c, okay, which is 99, to find out what letter in the alphabet it is, so where is it at in the alphabet, I'm going to subtract little a, okay? Because what that will do is that will say 99 minus 97 is equal to 2, which is odd, I know, but it's because the letters are inclusive, okay? So what that will give us is I need to go 2 spaces from a capital A, because little letters are the same distance from little a as they are from big A, because a letter is just a letter, it's where it's placed in the alphabet. So then all I have to do is move out whatever I get from here, so whatever this gives me, I need to add it to a capital A to find out how many spaces to go from. So I know that I've got to go 2 spaces from capital A. So what that means is I'll get 99 minus 97 and add on a capital A, which is 65, and that will give me 67, which is actually capital C. So you are playing around with the letters of the alphabet as opposed to minus 32, okay? So whilst you can potentially have minus 32, that's not good coding practice, okay? Because there is going to be ways that you cannot do it, and we're going to talk about more of that in a second. It is a lot more efficient to play around with the actual letters of the alphabet, and it makes a lot more sense if someone is looking at your code who comes along after that. Okay, So we've got 5 more minutes. Why not we do this part here first? So let's read the input from the user, okay? So to read the input, we'll use scanf. Again, we're going to need to place this letter into something. So let's read that letter. Let's say we're going to have a character, and it's going to be a lowercase letter. And again, the spelling is becoming a bit of a Tuesday morning issue. Okay, and then I'm going to have, I think, an uppercase variable as well, where I can convert something to it. Okay, so first of all, let's take in our, so I'll have a prompt for the user that will ask them to put in a lowercase letter. Okay, and then I'm going to take that letter in by using my scanf function, okay? And I'm going to take in a character, so I'm going to do a %c, okay? So if I have my %c, and then I'm going to tell it where to pop that letter into, and I'm going to pop it into lowercase, which is the variable that I've saved for it. Okay, so now this should have been able to read my character. Okay. And we haven't yet talked about what can go wrong here. So what can go wrong here? Again, if I have a scanf and I'm reading in a character, what can go wrong? How can I break this? How can I break this? What do you reckon? Yeah, someone doesn't put in a char or someone puts in a number, absolutely, and then it will be broken again. So I really need to be able to check what I've scanned in and whether I've scanned in something and it's been successfully stored into my variable, okay? So I'm going to just put in this, this variable again, this scanf return variable again, to show you what scanf returns and what scanf is doing, okay? So let's have a look. And in this case, I expect it to be one character read. So if one character is read, then again, my scanf return should have 1 inside it. Okay. So if we just do that, before we do anything else, I'm going to just have this here. So scanf returned %d so that you can see what it's doing. And okay. If I just run this now, that's still not doing anything except for taking an input from the user and then just telling me what scanf returned. And I've just compiled the wrong thing, sorry. So I'll do this and then we'll take a break after that. Okay, so let's have a look. I've got a few warnings. I've got a few things happening because I haven't quite finished what I'm doing, and I actually haven't used a few variables like uppercase and stuff, so it's giving me a few warnings. And the other thing it's telling me is that I haven't actually assigned scanf return to anything. So I've declared it here and I've used it here, but I haven't initialized it. Okay, so that's a bit of a problem. So I'm going to put it in here as something that I will make equal to this scanf. So now it's been used, and I'll try and compile this again. Okay, so now just one unused variable, which I haven't used yet, so that's all right. So if I run it now and I put in a lowercase letter, then it's telling me that scanf has returned 1, okay? Now if I run it again, and this is something I'll leave you for the break, I'm going to run it again, and instead of putting in a letter, you guys have said correctly, I can put in an int. So let's say I put in 1, okay? What's it going to scan in? Oh, scanf has returned 1. How tricky. What has happened? Why has it returned 1? And I'll give you a little bit of a hint here. I'll run it again, and instead of entering a number, I'm just going to press enter, and you can see that it returns 1 again. Okay, so this is something I'll leave you with for our 5-minute break. Okay, so let's have a 5-minute break and then we'll come back and we'll talk about what is happening here. All right, and keep popping your questions in the chat. All right, how exciting, we're back. And I saw some people were getting why this is still returning 1. And also I'm super annoyed by the terminal prompt being on the same line. So let me just fix that by putting a new line in so that I can get over how terrible it looks. Okay, and let's run it again. So let's run it again to remind you what's going on. So if I put in 1, press enter, it's returned 1. If I run the program again and I press enter, it still returns 1. My goodness. And I saw someone actually kind of picked what's going on. So someone in the chat has said that it's because 32 is actually a space, okay? My camera is missing. Oh, I'm sorry. Did you guys miss seeing me? Yes, there we go. I'm back. I'm back. Thank you, Shrey. Okay, so 32 is a space, but I wasn't pressing a space. I was pressing an enter, okay? And the enter is over here, okay? Number 10, you probably are going on, what is LF? What on earth does that mean? This is called old school. It's called a line feed. If you ever used a typewriter, that is what a new line is. When you change lines on a typewriter, you do a line feed. So number 10 is actually enter. So in fact, scanf, because number 10, it's a character. Enter, pressing enter is a character. New line is a character. It is taking in a character because the ASCII table actually includes these non-letter characters as well as letters. So when you press enter, you're actually entering in a character and it's reading that character successfully. However, when you then go on to do something here, you're now going to have the value of 10 and a value of line feed. So you're going to have some really bizarre calculations happening, okay? So there is a way to combat this, okay? So I have sort of banged on quite a bit in the %D, how %D is really neat. You know, it skips all the white space. It doesn't care about the new lines. It doesn't care about the spaces. Well, %C does, because those spaces and those new lines, they're actually part of the ASCII table. So they're considered characters as well. Okay, so what you can do to ask it to skip any leading white space, okay, if I don't want it to consider any white space at all, when I do my scanf, what I do is I put a space before that %C, okay? So instead of just having %C, I will put space %C. And what this space now tells the code is it tells it to please skip any leading white space. Please, you know, ignore all the sort of stuff that comes beforehand. I'm looking for a character, okay? So if we run it now, okay, and someone is saying we want to check that it's lowercase, we absolutely do, and that is an excellent way to break it, and we are definitely going to check that it's a lowercase letter that was put in. So now if we compile it again, okay, and let me clear the screen, and we run it again, okay, if we enter a lowercase letter, it returns 1, okay. If I run it again, I put in a number, press enter, it's returned 1. If I run it again and I put in an enter, and enter, and enter, and enter, and enter, and enter, and enter, it's not returning anything, okay? It's not returning anything until I put in a character. And the reason for that is because I've put that space before the %C. And that space has stalled it. Please ignore all of this. Please ignore it until you get a value, okay? And that's what it's doing right now. It's ignoring everything except for this %C afterwards. Okay, and can you tell me why, when I did 1 here, it scanned it in and it returned 1? So it's telling me that scanf was successful and it has in fact scanned something in. Could you tell me why it's doing that? What do you guys reckon? Yeah, so why is that number counted as a character? So I brought up the ASCII table for you to have a look at. Why do you reckon? Yeah, that's right. 1 is on the ASCII table. So 1 is being read in as a character because 1 is over here from 1 to 9. Actually, sorry, from 0 to 9, you have the characters 0 to 9, and they have the ASCII values associated with them. So Scanf has read in the character of 1, and the int that's sitting in there is 49 because that's the integer that's associated with the character 1, okay? So basically, anything on this ASCII table is considered to be a character and will be scanned in successfully. When you tell it that space %C, you're telling it to please ignore, you're basically telling it to ignore the leading space that leads up to a character being input. So what we can then do, now that we've accounted for space, is we can now check that the person has entered something that is a lowercase letter. Now, as you can see conveniently and also logically, it does make sense. On the ASCII table, your letters are actually in alphabetical order, which is really quite neat because it means that we can use comparisons and they are associated with numbers. So if you entered a lowercase letter, you can check, is something between my A and between my Z? Because that just means, is the number that is stored between 97 and 122, is it part of a lowercase letter index? So we can now check, we've scanned it in. Well, we should check if it's been successful. So, and that it's scanned in something. So how will we do that? So if it's returned 1, okay, which means that it's scanned in a letter or a character, then we can check if that character is indeed between A and Z, okay? So first we'll check if something has been scanned in, let's say. So let's check if our scanf return variable is equal to 1, okay? So remember, we use 2 equal signs to say equality in C, and 1 equal sign means assign a number to something. So 1 equal sign is assignment, 2 equal signs is actual equality as you're used to seeing equality. So let's have a look. So if it's equal to 1, so that means something was scanned in by scanf. So we scanned in 1 character. Okay, then, yeah, so Lisa's got it, almost got it. The only thing that we need to do, except for loser case, I hope that I'm not checking for loser case, but it looks like your spelling is as good as mine on a Tuesday morning. Fantastic. I'm probably about to write that. But your letters have to be in single apostrophes, okay? When you put something in single apostrophes, what that means is that it is a character, and please refer to the ASCII table to find out where that character is, okay? So I want to check that my lowercase letter is greater than A. So I want to check if my lowercase, my lowercase is got to be greater than or equal to A. And remember here I would use and. My lowercase has to be less than or equal to Z, okay? That means I am now checking whether or not my letter that I've put in is actually between A and Z. So I've got to be greater than A because I've got to be numbers that are more than 97, and I have to be less than Z because I want numbers that are less than 122. So if it is a lowercase letter, that means I am ready to start converting it to an uppercase letter, okay? So that means I'm going to assign my new letter or my uppercase letter to my variable uppercase. That's where I'm going to store it, okay? So what will I do? Okay, so here we worked out that I take my letter. So first I'll take the letter that was given to me, which is lowercase. And what I'm going to do is I'm going to subtract little a, okay? Because I know that it is a lowercase letter, okay, I'm going to subtract a lowercase a, because what that's going to do is it's going to tell me what number my letter is in the alphabet, or how far away is it from A. Okay, it's going to tell me where do I land up on this letter, where is this letter. And then I'm going to add it to a capital A because I want to move the same number of spots that this letter was from little a. I want to move that same number of spots from big A, because our lowercase alphabet is exactly the same as our uppercase. The letters go in the same order. Okay. So what that will do is that will convert and give me an uppercase letter. Okay. So now let's complete it by saying print F, and we can print F, and then we can see as well. So next week we're going to look at, how to style your code a bit nicer, and we're going to return to some of these and tidy them up, because some of these do not look that nice. Okay, so the capital letter is, and I'm going to use a %C format specifier, and I'm not going to forget a new line so I don't get annoyed at how ugly that looks. And I'm going to put in an uppercase as my variable because I want to print out the uppercase letter. Okay, so I have this lovely thing here. So I've checked that I've scanned something in. If I have scanned something in, I'm going to check that it's a lowercase letter and do a conversion to make it go to an uppercase letter. Okay, and now what happens now? What should I do now? What should we do now? What else should I account for, do you think? What do we reckon? Well, I think if it's not a lowercase letter, yeah, so someone said an else, and my else here, this else, is attached to this if. Now, if you were to, I'm just going to stretch out this screen a little bit so it looks a bit better so you can see how it goes. So if you look on here, that else, and you can see how I'm indenting things and where my curly brackets finish, it makes it much easier to see what relates to what, okay? Yeah, so that's right. So I'm going to return a 1, but before that, I need to let the user know why I'm just quitting the program. Okay, so it's not, I mean, I think many of you would have been very frustrated over time when you've been using some sort of application and suddenly it just quits, or suddenly it gives you an error message that says, index error 0, and you're like, what does that mean? So that is not the kind of error messages that we want to see. We want to see nice error messages that tell us what has happened, okay? So in this case, I've checked if it's a lowercase letter, so that means they didn't enter a lowercase letter. So I can say, you did not enter a lowercase letter, okay? And we can finish it there. And then what I can do is I can return 1, which means that I'm going to exit this program. I'm not going to do anything else. And I'm going to exit it to say that it did not finish successfully, okay? What it means is it's going to leave this program, but it did not finish successfully running. Something has gone wrong. That's what that return 1 means. So let's try it out, okay? Let's have a look. Let me clear this screen and compile again. Compile and run it again. And let's do a lowercase letter. If I enter C, then my capital letter is capital C. If I run it again, I put a little a, capital letter is A. Now, what happens if we do something that is not, let's do a Z, because that's, so you see I've done an A and I've done a Z, because both A and Z are my boundary conditions. So they are sitting on the outskirts of my comparison. So that's where you want to be able to check, is it actually working? Have I done the correct boundary? Okay, so let's have a look now. What happens if I'm going to try and break it? Okay, what happens now if I put in a number? Okay, I'm going to put in a number. And even though it's scanned in something, it's scanned in that character 1, it's actually no good for me because I can't convert. There's no lowercase 1 or uppercase 1. I really just want a letter. And now it gets our error message, you did not enter a lowercase letter, and it quits out. And of course, I forgot to put a new line. Oh, so annoying. Looks so terrible. Anyway, so now that's, that's taking care of that. And if I run it and I decide to press enter 10 times and then I enter my character, that will not matter either, because I took care of that by putting that space in front of the %C format specifier. Okay, so it reads in this little s and it converts it to big S. Okay. So that's playing around with letters, which is, super exciting. And if any questions, just pop them in the chat. Okay, so, we've kind of seen how, so always try and think of, how can I actually break this? What can I do? What can I do to break this? And then try and counter that. Okay, so try and see, okay, so here we've checked that something was scanned in by the Scanf, so we've taken care of that error in case something wasn't. And then we also checked if it's a lowercase letter. So we're really kind of making our program a bit, we're proofing it. I don't know, we're baby proofing it. I don't know if that's the right term for it, but you can't expect the user to always put in the right thing. So you are looking ahead, you're looking at what can go wrong, and you are really you're really trying to combat that as well, okay? And there's many ways in which you can do it. Okay, so that was the lovely upper. Okay, so what I want to do now is I actually want to introduce you to a little bit of a new concept, actually. And what I will do is I'm going to go back to my slides for a second. Let me just go to the right slide. And what I'm going to do is we're going to talk about this lovely thing called a structure. Okay, so what on earth is a structure? How exciting. So far we have done exciting things. We've looked at ints, we've looked at doubles, and we've looked at chars. So we've looked at 3 different variables, and all those 3 variables have been defined by C. So what that means is that C makes these available to us. It tells us that this is an integer, and this is what the definition of an integer is. And if you remember from last week, the integer for definition is that it goes between negative 2 to the power of 31 to positive, 2 to the power of 31 minus 1. The definition of a double is something else. The definition of a char is that it's in the ASCII table, as we've seen when we scanned in even that one, because it was on the ASCII table, it scanned in. So C has defined these data types for us. But sometimes it's really handy to be, a bit of a wizard and be able to define something ourselves, because at times we come to a problem that requires us to join things together or to structure certain variables together into our own user-defined structure. So basically a struct is a way to create a custom variable, okay? And it's a variable that is made up of other variable. It's just like it's a bag in a bag, or it's a box inside a box inside a box with different things in that box. So it's like I'm creating a box of things, and there might be different things in that box that are somehow related to each other, because otherwise why would I want to bring them together? And one of the sort of really easiest examples of it, okay, can you guys think of any examples in real life where you can think of some things that you would like to put together to hold together? So things that relate to each other. What do you reckon? Yeah, so near a class of students, yeah, there would be things associated with each student. So you would have a structure that would hold a student. Fiam, Lego. Yes, I actually had a picture of a giant box of Lego to demonstrate a structure, but then I couldn't decide if it was a good analogy or not. But yeah, a Lego might have a structure because it would have, a color associated with it. It would have how many dots it is, the thinness of it or the thickness of it, blah, blah, blah. So it would have a number of properties associated with this one brick. So people are saying athlete age, height, weight, absolutely. A bundle of sticks, yes, could well be. Depending what you're saying, you might say each stick would have, which tree it came from or the length of that stick, blah, blah, blah. Yep, so wardrobe database, you could have something, but it's not quite a database. It's like a structure of one thing. So I might have a structure of a dress, okay? And that structured dress might have in it color, length, size. So it will have different things associated with just that one object. And then I can create different instances of that object. So it's like I'm creating, I'm creating my own structure. And one really obvious one as well is the coordinate, right? A coordinate we know from school as well. We're so used to, we always have an X coordinate and a Y coordinate. And that always goes together. And that's kind of going to be one of the examples that I use. Someone has said date and day. Yeah, so you could have, let's say my birthday will have a day, a month, and a year. And so that's actually 3 variables, isn't it? That's an int for a day, an int for a month, and an int for a year. But I want to really push them together because they're actually all related to each other. So instead of creating just, hundreds of variables that, make no sense, I actually have a structure that defines a birthday as having a day, a month, and a year. And then I can just play around with that structure. Yeah. So a struct is really, it's something that holds together different types of variables that belong together. And I can have a structure inside another structure. So let's say I have, a student structure. It might have a birthday. And then I have a separate structure of a birthday sitting inside that student structure because it belongs in there. So it's like a mixed bag inside another bag, inside another bag. So you are creating this awesome, struct. And yeah, definitely vector is a great example of a struct as well, because you could definitely store different aspects of a vector inside a struct that relate to that struct. So yeah, absolutely. You guys are doing great. So we'll go across. So on my lecture notes, I've also defined how to do a struct. But I'm going to go over to my code and do it in the code. But basically, in a struct, there are 3 main steps that you need to do. Okay. So first of all, and I guess logically as well, we need to define the struct. Okay. So what on earth is this structure going to contain? Because you're making up this structure. Okay. You are defining this structure. The computer doesn't know what it is. You need to define what is going to be in it. So that's the first step. You define it. And you define it outside of your main, so it's available to everything that you're doing, okay? And we will talk more about that next week, where things belong, but you define a struct outside the main. Then you're going to do in exactly the same way as you work with your variables. Your variables, usually you will declare a variable, and then you will initialize it. Okay, and that's what we're going to do. We're going to declare the struct inside our function. So we're going to say, we're going to give it a variable name, and we're going to say what type it is. So we're going to refer to that type of struct that we created. Okay, and then we're going to initialize the struct. So we're going to give it some values, okay, because otherwise what's the point of having it if we're not storing any values in it? So 3 steps: define, declare, initialize. If you want to make a dance of it, please do. Please share on the forums. So let's go back to the code and we'll see it in action. Yeah. Okay, so introducing you to structs. I wish I had a drum so I could do a drum roll. But basically, a mixed bag of tricks. You are in charge of defining it. You're in charge of saying what it is. So 3 main points is define, declare, and initialize. So we need to be able to do those 3 things to be able to use a struct. Okay, so let's say I have the following problem. I have the coordinate points of 2 points and want to compute the midpoint of the line the 2 points make. So, yay, we're going to be going back to high school to calculate midpoints. How exciting. Okay, so first of all, I'm going to define a structure that's going to be like a coordinate point. So I want to hold an X and a Y. I want them to be together as one because they are one coordinate point. Okay, so outside of my main function. So as you can see, I'm defining outside. I'm going to first of all define. And to define, we're going to do a few things. So I'm going to tell C that I'm defining a structure. And to do that, I'm using the keyword struct. That is what's telling C, hey, I'm about to be the boss here, and I'm going to define the structure, and I'm going to tell you what's going to go inside it. And I'm going to give this structure a little bit of a name. This is not the variable name of this structure, but this is the name of this. So it's not the variable name that refers to this structure, but this is what I'm calling this structure. I'm calling it a coordinate, okay? Ah, yes, you are right. All right. You know why? It's because I had a gradient there first, and then I changed my mind, and I went from a gradient, good pickup, and I went from a gradient to a midpoint because I thought it'd be easier. Okay, now when we define a struct, okay, when we define a struct, we use curly brackets, okay, because it's a definition. And very important is that we also have a semicolon to finish our definition. So we're telling C that we're about to finish this statement, to finish defining this struct, okay? And you will later learn why that is. There is a reason for it, and it's because something can go here as well, in between the bracket and the semicolon. But for now, let's just finish it with a semicolon, which will say that we're done defining this. So let me save it so that you guys can see it. There you go. Okay, so inside my coordinate, I'm going to have two things. I'm going to have an int x and an int y, because my coordinate point is made up of an x and a y value. So now I have a definition of a structure. That structure is called a coordinate, and it's got two things inside the structure. It's got an int x and an int y. So each coordinate point has an x and a y value. Now I go inside my main. So I finish the definition stage. Now I'm going to declare it. So I need to let C know that I'm actually going to use this structure now. And that's what you do when you declare it. You let C know that I'm going to use something. So I'm declaring to you, I'm letting you know, could you please save some space for this structure, okay? And in this case, the space that's going to be saved each time this struct is called is space for two integers. So to declare it, what I do is I use the name of the struct, okay? Because this is now my data type. So I'm telling C, I want a variable name of type struct coordinate, which is what this struct is called, struct coordinate. And then you give it a variable name, just like you do normally, okay? I don't know, what should it be? We have two coordinate points, don't we? So let's do point 1 and point 2, because I'm very creative like that. And then we can do another coordinate point, and it's got the same structure. It's going to have an x and a y, but this one is going to be called point 2. So now I have two coordinate points that I've declared, okay? One is point 1 and the other one is point 2, okay? Now, before I go on, I also want to initialize those. So the same way as you would a variable, you need to be able to put some values into these. Otherwise, what's the point of having them? We really want to have to give these variables some value. So we've defined it, we've declared it, and now we're going to initialize it. So let's take these coordinate points from our user. Why not? Okay, so let's do a prompt for our user. And since we've been using Scanf this whole lecture, let's continue using Scanf to take some input from our user. So let's do a printf and let's do please enter the x and y coordinates of point 1. Okay, and then I'm going to scan in those two coordinate points. Yeah, so I know that my coordinate points, the x and the y, they're both ints, aren't they? So if they're both ints, then what happens here is that I'm going to be scanning for a %d and a %d. I want to take in two numbers, which is %ds. So now the fun part comes, and that's how do I load it in to a member of the struct. Okay, so the same thing as before that you've used Scanf, you still have to have the ampersand. The ampersand always has to be there because you have to tell it where to find this variable for the value to go into it. So let's say this is point 1. Okay, the variable name of my point 1 is point 1. So as before, I'm going to say I'm going to go into point 1, and that's exactly how we've used Scanf in the past. We've said what variable name it will go into. But I have two options now, because point 1 is actually a structure, and it's got an x and a y component to it. So you need to let the computer know, or your code know, where does it need to go, into which member of the structure. Does it need to go into the x coordinate or into the y coordinate? And to do that, you use a dot to say, I want it to go into the x coordinate, okay? So the x here refers to this x here. So you've scanf'd as before, and you've done point 1. You use a dot to access the member of the structure, and you've accessed the x component of it, okay? So that means the first number, I want to go into point 1.x, and the second one, I want to go into point 1.y. So what you've done is you've accessed the member of that structure, and you've put it into there. So that will give me the first coordinate. Okay, now I want to do the second coordinate. So I'm going to do something similar to that, but I'm going to obviously ask the user for the next coordinate. So please enter the x and y coordinates of point 2. Okay, and then we'll have scanf again, and again we're scanning in two numbers, so we have 2%ds going for us, but this time we're putting them into point 2, which is the variable name for the second point, but still we're putting it into the x member, and the second one we're putting into the y member. And to do that, you do, oh yes, thank you, whoever, yes, thank you, Zach. A lot of, I will print out now, and then I will do, okay. So now before I do any calculations, what I'm going to do is I'm going to print out what we've scanned in as well, okay? It seems counterintuitive. It's just for us to test it. And then we'll talk about all the different things that can go wrong as well. So let's just see what has happened and what we have printed out. So, sorry, and what we have scanned in. So let's printf. Let's do point 1. And point 1 will be %d. And thank you, Zach, for the reminder. I'm going to have a new line, and I'm going to have point 2. And point 2 also is going to be %d, and new line again. Okay, and now for my variable names, again, it's the same thing that I'm doing here. So my first variable is point 1. But I want to access the x part of it. And then I want to access the same point, but I want to access the y of it. And then the same thing for point 2. First I'm going to access the x, and then I'm going to access the y. Okay, and then that's we haven't really done any calculations yet. Someone doesn't think I closed off a bracket. I have not closed off a bracket, nor have I put a semicolon. Good spotting, well done. Yes, very good, well done, guys. And did I? Yep, I did. Good noticing. Okay, so let's have a look. Let's compile. Okay, and then let's run. So on the first run, what I'm going to do is I'm going to put in like correct values. We're not going to break it on run 1. So please enter the x and y coordinates of point 1. Let's say it's 1 and 2. And of point 2, I'll do 3 and 4. And now it's telling me point 1 is 1, 2, and point 2 is 3, 4. So very neat. It's come together. And someone's asked a really good question. Is there a way to print a struct rather than printing the different components? No, because the different components, so your struct might have different things in it that are of different types. So in this case, we have, we have both a %Ds, but we might have a %C in there. We might have a %LF in there. They don't necessarily all have to be of the same type. They can be of different types. So, which is why you would specify which component it is that you want to print, because each component will have a different format specifier as well. So for a char, you would use a %C. For a float, for a decimal number with decimal points, you would use a %LF. So, yeah. Okay, so we have created a struct by defining it. We've declared it that we're going to use it. We've told C, we're the boss, we're going to use this. And then we're going to initialize it. So we gave it some values, and then we printed out those values. So now let's do the calculation, okay? So let's calculate our midpoint as well. So to calculate the midpoint, we have two components. We have a midpoint of x, and we have a midpoint of y. So I'm going to have two variables to calculate it and to place it into. I'm going to have midpoint x and midpoint y. Okay, and let me save it so you guys can see what's going on. Okay, so now that we've got our 2 points, let's calculate what our midpoint is. Okay, let's do it. So midpoint x is going to be equal to, I want to have the first 0.1 x, so to access it, I'm going to say 0.1, and I want the x component. I'm going to add it to 0.1, no, I'm going to add it to 0.2, the x component. So I want to add the two x's together, and then I want to divide the whole thing by 2, okay? Now, would anyone see any problems in this line 41? Do you think that this will always give us the right answer? And it's okay if you can't see whether it will or it will not. We will go over it. We'll do some, values that will give it, Okay, Lisa, brackets, I agree. You would definitely need brackets because right now that's going to do 0.2.x divided by 2 and then add 0.1 to it. I agree wholeheartedly. You absolutely need brackets to push the precedence that you want. Absolutely. Someone said BODMAS. Yes, very good. There we go. Someone has mentioned it. Nicholas, thank you. Integer division is really weird. Yes, it is, because it doesn't give us, when we divide up our integers, it gives us an int. So we'll see what's going on, okay? And someone is, so a few people are pushing it to be a non-integer division by dividing it by 2.0. That's pretty good as well. And we can have a look at that in a second as well, why it's doing that. Okay, so let's do midpoint y now as well. And we'll do it the same way. So and what I'll do is first I'm going to do it without this, just to show you what happens. And then we'll do it with it. So now I want to access the y coordinate. And the same for 0.2. I want the variable 0.2, and I'm accessing the y coordinate. And I'm going to divide that by 2 as well. Don't forget the semicolon. Okay, then we have the semicolon. And now instead of printing out all of this, I also want to print out, so 0.1, 0.2. And then I'll say they have the midpoint. and then I'll say which variables I want to use, and I want to use midpoint x and midpoint y. Okay, so let's see what that does now, okay? And a few people have commented that I might need a double. So before I do that, I'm going to do it without using doubles or without using anything, just to show you what happens. So let's do it. So I'll do, the first one is I'll do 1, 2, and then the next one I'll do 3, 4, because creativity is important. So what I did was perfection, because I did both end up even numbers and they divide 2 rather nicely. So if I were to try out, and I forgot a new line, but if I were to try out and I were testing my code and I wrote in this magical output that gives me even numbers that divide 2 nicely, I wouldn't actually find, I wouldn't really find, a problem in my code. So that's why it's important to try different things in your code to see if different inputs make a difference to what's going on, okay? So in this case, it's correct. 1 plus 3 is 4, and 4 divided by 2 is 2, and 2 plus 4 is 6, divided by 2 is 3. So that works nicely. But what happens if, I'm sorry, I can't focus without that new line. What happens if actually I'm going to do an odd number and divide it by 2? So something that might give me 1.5 or 2.5. So let's do 1, 2, and here I'll do 2 and 3, okay? So now each sum, 1 plus 2 is 3, divided by 2 is 1.5, and 2 plus 3 is 5, divided by 2 is 2.5. So now it's just going to give me 1 and 2, even though it should have been 1.5 and 2.5. And that's because I've divided an integer by an integer, okay? And if I've divided an integer by an integer, yeah, I didn't recompile it, so I still have that silly new line that's driving me insane. So what happens is that now I have, when I've divided an integer by an integer, what I get is an integer, okay? So in C, when you divide an integer by an integer, you get an integer. So someone has suggested that perhaps if I divide by a double, so I divide by a decimal, then that will fix my problem for me, okay? So if I compile it again, and if I run it, and let's do it again. So the first one is 1, 2, and the next one is 2, 3. Oh, and it's still saying 1, 2, okay? Now I'm dividing an integer by a double, and it's giving me an integer. So how else can you think we can fix this? And I think someone has mentioned it in the chat, but the chat has moved up so much now that I've missed it all. Yeah, so let's try saving the mid. What if we have our coordinates, or not coordinates, if our midpoints become doubles? What happens then? So I have both of these as a double. So now what happens is I might have a double calculation here, which means that also over here I would have to have an LF, not just a D, otherwise it will scream at me and not want to compile. Okay, so if I run it now and I say 1, 2, 2, 3, then now it's giving me, ugly, but it's giving me a lovely double. And someone has mentioned that, yes, I should shorten it to 1 decimal place, which we can do by just putting .1 and .1 here. And what that will do is it will shorten my answer to make it look more aesthetically pleasing. It will shorten it to 1 decimal place, okay? So if I do 1, 2 now and 2, 3, then it will give me actually a tidy number here, which is quite nice. Okay, so that's the basic of this struct. So now how else, what can go wrong? What can go wrong in here? What can go wrong now? How can we break it? LF stands for long float. It stands for a decimal number. Okay, how are we going to break it? Let's break it for sure. What happens if we divide something where its output is not rational? I'm not sure I understand the question. The user enters a character, yeah, it will break it. Inputs must be integers, so non-integer inputs bad. Yeah, okay. Oh, people are thinking of great ways to break it. Input a decimal. String, we haven't learnt about strings, but that will definitely break it. Inputting two chars, so let's break it. Okay, how am I going to break this one? I'm going to be annoying. Whoa, so if I put in two decimal places, it has gone, no, I don't think so. That is quite rude of you. You told me that your structure has ints, and now you're throwing me by giving me doubles. It's just very, very rude. So people are coming up with some amazing ways to break things. I really love this. It means I hope that you will be producing some amazing code as well because you know how to break things, okay? So how can we should X and Y coordinates, should they be a double, you know? What do you think? I mean, a point doesn't have to be an integer. It could be a double. We could change it to a double, can't we? So the points could be a double in here. It depends how our problem has been defined as well. So part of understanding where your limits are is also understanding what the problem definition is, okay? Someone also said that we could break it by entering in two characters. Indeed, if I put something like this, it's going to also not like me very much because, well, that doesn't make much sense. So that is something that we could counter for as well. We could make sure that something was scanned in, can't we? Which we have done already when we did our last part. Yeah, so exactly. So people are saying that's excellent. We can use, we can check that the user is entering, you know, a number. We can check that it's not, that something has been scanned in okay. And if you remember the way we did it last time is we checked that scanf is still operating exactly the same way. It doesn't matter that you're putting something into a struct. In this case, there's 2% Ds, so scanf is going to return 2 if it's successfully read something in, okay? So we can actually check, has scanf been successful in this case? Has scanf been successful in this case? So we did it before by using our lovely if statement, and we can do it again. Okay, so we had here, we assigned it an int, and we will look at how to do this more efficiently. You will not have to have an int assigned each time. I mean, that's not particularly efficient coding or nice style. And we will look at doing it, but I think it's more clear right now to do it like that. So whatever scanf is returning, I'm going to assign it to this variable scanf return, okay? And then I'm going to check that scanf is, if it's not equal to 2, then something's gone wrong, okay? So I'm going to say if this scanf return is not equal to 2, so that means if it's anything other than 2, okay? The exclamation mark is not equal to, is exclamation mark and an equals. And then I might printf a statement that will say that what your error is. Oh my goodness. And the error is that you you did not enter 2 coordinate points. And then I will exit out of it because there's really nothing more that I can do. And we're going to look at how to, you know, not just exit out of any time you have an error, how to give a user to an attempt to recover from the error. We're going to look at that as well later as we get more code under our belts. So if scanf didn't return 2 for us, then you did not enter 2 coordinate points. We can't really go on. Okay, now we did that for our first point. So now if we try to compile it, and then we run it, and now we're going to be tricky and I'm going to enter something that's not, then it's going to catch that before it gives me a whole bunch of very angry red errors, okay? And then obviously we would have to do exactly the same thing up here as well, okay? Because what happens, if you put in the right point for the first one, but not the right point for the second one. So you would actually have the same piece of code that would go over here as well. Oh, I didn't mean to save it. I meant to paste it. So I'm going to check again that I've scanned in 2 things again. And if I haven't, then I'm going to exit out of here. You can return something other than 1. You can return 1, 2, 3, 4, and you can return things also that you can then check for. So you can actually check what error is happening by returning a specific number. Okay, so we will learn more about that, and in one of your lab exercises we actually make you return something other than 0 in this coming week. For now, I'll just return 1s, just so that you guys get the idea. 0, you've been successful. Return 1, you have not been that successful. Something has gone wrong and we want to stop. Okay, so then we have now something that will counter for 2 possible errors, and you guys had a few more things happening that was, and I've forgotten what you guys have also said, but you guys had a few more suggestions of how things can go wrong. So now I'm making sure that I'm scanning in points and getting points, and I'm printing out points. Okay. Yeah, so the error, what happens is if I return 1 at this point, okay, or if I just have this return at this point, what it means is that I am exiting out of my code, okay? And when I exit out of my code, I'm not going to do anything that's below this code. So I don't have a chance to have an error because I've stopped it from happening, because I've stopped it from trying to read these points that don't exist, okay? And that's the reason that I catch the errors and I leave before anything has happened. And just a reminder again that C reads things from top to bottom, starting from, it starts reading at main and then it goes downwards, reading everything kind of thing when it enters code. So first it will see what libraries it needs to include, and then it will, maybe look at anything that you've defined here. But when it starts doing the instructions for code are just read from the main and you go from the top down. So it kind of, you have to branch it using if statements, or we're going to learn how to do other things as well. But you have to be able to branch it to be able to do different things or skip over certain parts of code if they're not relevant. All right. Tom, do you want to add anything there? Because we're going to finish up there as well. Tom, do you want to?
I'm not sure that there's anything else relevant. I think most of the questions have been covered in the chat.
Oh, well, someone wants me to put something other than 0 and 1. Absolutely nothing is going to happen, so I'll just demonstrate it. How about I put 100? Why not? Let's live a little. And that's on point 2. So what I'm going to do is on point, was it on point 2 or point 1? Point 1, okay. So I've returned 100, and now if I recompile it and run it, and I'm going to put the wrong thing in, nothing's going to happen. It's just going to exit it out, okay. That 1 is something that you can read afterwards to find out what the error was. But as a standard, when a person is reading your code, if they see a return of something other than 0, they know that there has been a mistake and your program did not finish compiling successfully.
It's worth noting that those numbers, there are more meanings that you can read into them, and that you can sort of go in further into it.
Yeah.
But the basic message is just 0 means okay, 1 anything other than 0 means not okay.
Yeah. And you can, as Tom said, there's things that you can return that tell you what error has happened, but you don't need to know that, and you don't need to know that in 1511. All right. Well, thank you guys for tuning in for this beautiful morning. And the weather has fined up. I think the weather enjoyed our lecture. So hopefully you guys get to go out for a little walk and have a little bit of a break after this 2-hour mammoth effort. But thanks for tuning in, and I look forward to seeing you all again tomorrow for another exciting adventure where we're going to loop-de-loop. We're going to do some looping.